This podcast is over getting to know the periodic table. So the first thing I want you to do at the top of your notes is to write the objective and highlight it. So we want to know and understand parts of the periodic table. Know and understand parts of the periodic table. All right, so the first thing that we're going to do is just look at each one of the squares that are on the periodic table. So make sure you have your periodic table handy. We're going to do several things with it. However, right now we're just going to kind of look at it and get to know it. So first part, looking inside the square, you're going to see that we have a little number at the top of, scroll to your periodic table that you guys have. You have a little number that is at the top of your that is the atomic number. Okay, so the atomic number is actually telling us the number of protons that is inside the atom. Number of protons inside the atom. So not only is it the number of protons, however, the number of protons equals the number of electrons, so therefore the atomic number is also telling us the number of electrons inside the atom as well. Now, it was clear back when they were coming up with the design for this periodic table that there was a professor, Mendeleev is his name. Mendeleev wanted to figure out a way that he could organize it so that his students could better understand this periodic table. Before, they had a way, they were putting everything according to the smallest mass and then kind of increasing on the way down. Now, he figured this out by playing a game of solitaire. You guys might have all played solitaire before, but if you notice when you play solitaire, you order your cards according to suit, and usually you do it from ace to king in each one of those suits. Okay, so they're ordered from smallest to largest by color and by suit in each one of your columns. Okay, so when Mendeleev was playing this game, he's like, aha, you know what? I think that the periodic table could have something similar. So he did the exact same thing. He took all of the elements that were known at this time and he ordered them in each column according to common characteristics from lowest mass down. Okay, now today's periodic table is a little bit different. It has been developed a little bit more since then, and somebody realized that, you know, we can't organize it that way because there are some elements, their atomic mass is larger, and we actually have it placed somewhere else on the periodic table. So now we order the periodic table according to the number of protons, because they found out that each one of these elements has a different number of protons. So that is a great way to identify what we know about the periodic table. Okay, so how do I find the number of protons by looking at the periodic table? Well, like I said, the number of protons is the atomic number. How do I find the number of electrons? It is the atomic number. Okay, and the last subatomic particle is the number of neutrons. How do I find the number of neutrons? Well, I'm going to jump ahead and do average atomic mass first. On the periodic table, you're going to see the average atomic mass is right underneath the element name. So the element, their average atomic mass, you'll notice, is usually in decimal form. Okay? Now the reason why it's in decimal form is because each of these elements, they're found in nature in many different masses. Okay, so the reason why they do the average atomic mass is because they're taking the average of the elements, of all of that particular element, and they're just taking the average of it. So average atomic mass is the weighted average mass of that element. Okay, so now back to how do I find the number of neutrons? Well, we can't exactly look on each one of those squares and it pop out and say this is the number of neutrons. To find the number of neutrons, we actually take the average atomic mass, we round it to the nearest whole number. So we take average atomic mass just going to write rounded here. Subtract the number of protons and that is going to give me the number of neutrons. Okay, so for example, if I go back up to this box up here, okay, I have an average atomic mass of 1.01. If I take that and I round it to the nearest whole number, it's 1. Okay, and then I take the number of protons, which is 1, and subtract it from that. That's showing me I have 0 neutrons, which that's true. If I jump ahead here to the periodic table, I'm just going to pick out another element. Okay, let's pick out boron right here. Okay, so boron has an average atomic mass of 10.81. Okay, if I take that 10.81 and I round it to the nearest whole number, so I look at this decimal place, it's an 8, so that means I round it up to 11. So I take 11 and I subtract the number of neutrons, minus 5, I can find the number, subtract the number of protons, I can find the number of neutrons, which is 6. Okay, so I have 6 neutrons in an atom of boron. Okay, so not too challenging to find. All right, so back to these notes. Now the periodic table, if you noticed, is also organized into columns and rows. Okay, these columns are what we call groups. Columns are groups. And if you look at this image that I have here, you'll see that I have 1, 2, 3, 4, 5, 6, 7, 8, and it's skipping all of these. But really, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 different groups. And if a column is a group, then a period is another name for the rows. And looking at my image, 1, 2, 3, 4, 5, 6, we have 7 rows. Okay, now you'll see the A's next to that, which I'll get to that soon. That kind of helps us identify another aspect of each one of these elements. And you'll also see on this particular example that there's names going across. Like group 1 is the alkali metal family. Group 2 is the alkali earth metal family. Group 3A over here is the boron family. So each one of these actually have a name that go along with the characteristics. Is lustrous. Okay, lustrous just means shiny. Another characteristic is malleable. Malleable means that it can be hammered without shattering. Also, it is ductile. Ductile means it could be put into a wire, into wires, which metals are very important to put into wires because, as we just learned, we're going to use metals to put into wires for our electricity. Good conductor. It is a good conductor of electricity, so it means transfer heat and electricity well. Okay, or it can allow the flow of electricity. Okay, so a nonmetal is going to be non-lustrous, so it's not going to be shiny. It's going to be a poor conductor. At room temperature, most of them are going to be brittle solids, liquids, or gases. Okay, so a metalloid is going to contain the properties of both metals and nonmetals. All right, so key vocabulary term. You need to make sure that you understand what a valence electron. When we get into actually showing the electron models of each of these elements, you'll see that a valence electron is the electron in the outermost shell of element. All right. So this concludes the podcast, Getting to Know the Periodic Table.